Alright, good morning guys. We are starting the last part of chapter 8. We're talking about inequalities today. I don't think you guys have maybe studied these before, but they're kind of like equations, but they're also kind of the opposite of equations, and hopefully that'll make sense in a minute. But an inequality is a mathematical sentence just like an equation is. The only difference is an equation will tell you what something is equal to. We're using the equal sign, and inequality uses 4 different symbols, and I know you've already learned about 2 of them before. There is the less than symbol, there's the greater than symbol, and now you have 2 new symbols, and they're the less than and the greater than symbols, but there's a line underneath them, and that just means or equal to. So this is less than or equal to, and this one is greater than or equal to. And so an inequality is a mathematical sentence that compares expressions. It contains the symbols less than or equal to, and greater than or equal to. To write a word sentence as an inequality, look for key phrases to determine where to place the inequality symbol. And so we're going to just practice writing inequalities, and it's just like writing an equation. You probably want to use these keywords to help you, but you're basically just writing kind of an expression. It says a number C is less than -4. So you're like literally translating this into a mathematical sentence. So it tells you to use the variable C. So C, and then is less than. If you look at the chart up above, is less than is a symbol for the, is a keyword for the less than symbol. And so it says less than -4. And so both of these, the number sentence that I just wrote and the word sentence, they mean the same thing. They're just written 2 different ways. So letter B, K, a number K plus, means add, 5 is greater than or equal to 8. So if you look at the chart, it looks like this, and then 8. And you read that the same way. K plus 5 is greater than or equal to 8. And then letter C, 4 times a number Q. So you remember 4, we're going to use the dot for times. Q is at most, which means less than or equal to, and then you would say 16. The other way that you can write this is, that's a 6. Get rid of the multiplication sign and write 4Q less than or equal to 16, because when there's the coefficient right in front of the variable, the number in front of the variable, it means to multiply. So you guys use the keywords, try the 4 try-it questions, and then check back in, and we'll move on to the next thing. Okay, so number 1, a number is greater than 1, a number n. So n is greater than, looks like that, 1. Number 2, twice a number p. That means twice means multiplying by 2. So 2 times p is fewer than, means less than 7. You can also just write it like that. We're going to try not to use the x because that might, an x for multiplying, because that might look like a variable. Number 3, a number w minus 3. So w minus 3 is less than or equal to 10. So you literally take it step by step and you rewrite it into the math sentence. A number z divided by 2 is at least, means greater than or equal to, -6. So if you don't have all your keywords memorized, just keep going back to look at the chart up at the top. Okay, we're moving on though to part 2, and now we're gonna practice 2 other things today. So the first thing we need to do is talk about solutions. And so when we talked about equations, we would say like x is equal to 5. That means that the letter x had to be equal to 5, otherwise the equation wouldn't work. But an inequality can have multiple answers, and you'll kind of see that in a minute, but the vocabulary here is what I just said. A solution of an inequality is a value that makes the inequality true. An inequality can have more than one solution. The set of all solutions in an inequality is called the solution set. And so like on this one, on these, it says tell whether the given value is a solution of the inequality. And so they give you over here, it says if x is equal to 8, would that make the inequality true? So if you plug in the value of x into the inequality, so that's x is 8, instead of x plus 1, now it would say 8 plus 1 greater than 7. Is that a true statement? If you work out the left side, 8 plus 1 is 9, greater than 7. Is that true? It is true, so yes, this is a solution. Okay, letter B. 7y means 7 times y is less than 27 when y equals 4. So plug in 4 for y. So instead of 7 times y, now it'll say 7 times 4 less than 27. Is this true? 28 less than 27? You should say no. You can draw a little line through that, which means not equal to, and you would say it is not a solution because that didn't work. And then finally, letter C, it says 5 is greater than or equal to z over 3, or z divided by 3. So 5 greater than or equal to, z is equal to 15, so it's going to say 15 over or divided by 3. So work this out. 15 divided by 3 is 5. Is 5 greater than or equal to 5? Yes. So this letter C is, is a solution. Okay, so example 2 is just substituting. You're checking to see if these are true statements or are they not true. So it says for the triads, tell whether 3 is a solution of the inequality. You guys pause here and then come back and check your answers. Okay, so does 3 work for all of these inequalities? If b is equal to 3, 3 plus 7 is less than 6. Oh, I don't know why I said 7. Sorry. 3 plus 4 is less than 6. That is equal to 7. Is that less than 6? No, it is not a solution. Then try the next one. 9 minus n, we said is 3, greater than or equal to 6. 9 minus 3 is 6. Is 6 greater than or equal to 6? Yes. So it is a solution. I'm making check marks. That's a check mark, not a V. And then the last one, 10 is less than or equal to 18 divided by x, which is equal to 3. 18 divided by 3 is 6. Is 10 less than or equal to 6? No. So the last one, number 7, is not a solution. Okay, so then this next part, we're going to graph the solutions. This is when I talked about how you're going to see that something could have more than one answer. So the words up here are walking you through what I'm trying to tell you or explain to you. It says the graph of an inequality shows all the solutions of the inequality on a number line. An open circle is used when a number is not a solution, a closed circle when the number is. An arrow to the left or the right shows that the graph continues in that direction. Okay, so what this is saying is, first you're going to make a number line. And when I make a number line for inequalities, I don't make it very big. I usually put the number that we're talking about, 2, in the middle, and I usually just honestly put one number higher and one number lower. I draw little arrows to show that the number line will keep going. And so it says graph g is greater than 2. And so I'm saying that g could be any number in the world that is greater than 2. And to show what that means, I'm not going to spend like the rest of my life listing out every number that's greater than 2, because you could go on forever. I could mean 2.1, I could mean 3, I could mean 5, I could mean 100, I could mean 1,000,000, any number that's bigger than 2. And so I can't list them all out, so instead you use a number line to graph what you're talking about. So first, it says greater than 2. And so if you think about it, the number 2 is not included in that because 2 is not greater than 2. And so it says an open circle is used when a number is not a solution. So 2 is not included, but you still mark it because that's kind of where you're starting or what you're talking about. So you put a circle around 2, it's not colored in because it's not included, and then you use an arrow going either to the left or the right to show that the graph continues in that direction. Since I want numbers greater than 2, that means that my arrow that I'm drawing goes to the right. And I'm showing you that I'm talking about every number bigger than 2, and an arrow shows that it will keep going up and up and up. I usually draw my arrow on top of my number line. I think some other teachers maybe might have you draw an arrow above the number line because when you use a pencil it's hard to see, but since you're doing this online, I guess that doesn't matter. But either way is fine, your arrow should be going to the right. So if you come down here to the triads, letter A, or number 8, letter A is less than 4. So draw a number line, put 4 in the middle, 5, 3 is less than that. And you want to mark numbers, any number that is less than 4. So again, 4 is not included because 4 is not less than 4 itself. So an open circle, and then numbers less than 4 are going to the left. So draw an arrow or make this side thicker. Show me that we're talking about numbers less than 4. Number 9. F is less than or equal to 7. So here's 7. 8, 6 would be 1 less. Okay, so on this one, when I say less than or equal to 7, this is now a closed circle because it is now including 7. It's equal to 7. I also want numbers less than that, so again, that's going to the left. Go ahead and try these other two. 1 less than 0 would be -1. Greater than 0, so does not include 0, but any number greater than that is going to the right. And then the last one, number 11. Okay, so this one is written not backwards, but it's written differently. It says -3 is less than or equal to p. And so your graphs, when you're graphing inequalities, you are graphing what p is equal to. So if -3 is less than p, you kind of have to reverse this and think that p is greater than or equal to -3. So your graph should be a closed dot because it says or equal to, and it is pointing to the right. Numbers bigger than that. All right. Last few examples. Number 4. It says the NASA Solar Probe Plus can withstand temperatures up to and including 2,600 degrees Fahrenheit. Write and graph an inequality that represents the temperatures the probe can withstand. I think this is important, up to and including. So pick a number that you want to stand for temperatures. I want to pick T, and so I'm saying like temperatures can withstand up to and including. That means that temperatures have to be less than or equal to the 2,600. Otherwise, this thing will melt. So that's the inequality, and then you want the graph. I'm going to do 2,700 is bigger. 2,500 is smaller. So I want to include that because it can get to 2,600, but it cannot go past that. And so we have to show numbers less than that. You guys try the try it questions real quick. The farthest a drone can fly is 200 meters. A building is 380 meters tall. You control the drone from a floor that is halfway to the top of the building. Can the drone reach the top of the building? Explain your reasoning. If you think about this, I might draw a little picture here. Here's the building. We said it's 380 meters tall. And you are like halfway. That's a window. Half of 380, if you divide that by 2, is 190 meters. And then it says that the drone can fly or can be 200 meters away from you. Can it reach this 380? So if you're halfway up the building at 190, the drone goes up 200 meters. Will you be past the top of the building? If you add 200 to 190, you get 390. So the drone can be up here, which is 390 meters, and that is above the top of the building. So yes, if I'm at 190 meters, the drone can fly up to 390 meters, which is above the building. Okay, last one. Each visit to a water park costs $19.95. An annual pass to the park costs $89.95. Write an inequality that represents the numbers of times you would need to visit the park for the pass to be a better deal. So if you buy like a season pass, I guess, you have to pay the $89. One visit is $19.95. So it might be cheaper to get the annual pass, but that would depend on how many times you go. So if you choose a letter like P to stand for the number of times you go to like the water park, you're saying that each time you go, you pay $19.95. You're multiplying that times the number of times you go, and that number should be greater than the $89.95 for it to be a better deal for you. Okay, that is the end of lesson number 7. Next time we're going to practice solving inequalities. Let me know if you guys have any questions. Thank you for watching.